Assalamu alaikum. Can you see the slide?
Yes, sir. We can see the slide, sir.
So today we'll finish the properties and uses of aggregate. Some slides are left. We'll discuss properties of engineering materials. We started this topic aggregates with engineering materials, where we discussed what is the importance of engineering materials, what is engineered materials, what are the engineering materials, and we had some discussion with that. And later on, we discussed about aggregates. Now, here we will discuss about few properties of engineering material in general. But in subsequent classes, you will be coming across with those terms. For the time being, know that there are some various types of properties of materials, like physical properties that include size, shape, density, porosity, structure. So these are the physical properties of material. Then there are some mechanical properties, that is strength, elasticity, plasticity, stiffness, ductility, malleability, hardness, brittleness, resilience, and creep. Today, actually, I'll make a short discussion about the mechanical properties only. Okay, and there are some chemical properties like corrosion resistance. We'll have separate chapter for that. Then alkalinity and chemical composition. Chemical composition part will come from material. When we discuss about cement, we'll see what is the chemical composition. Okay, so it will come occasionally. Thermal properties, it may come sometimes. It will come when we'll be reading fiber reinforced polymer. At that time it will come. So there are three types of thermal properties I'm going to introduce. One is called specific heat. Specific heat means the heat required to raise the temperature of unit mass of a substance by a given amount, normally 1 degree. Okay, so how much? What is the if you apply a certain temperature, a certain amount of heat, then the raise of the temperature by a unit, a single unit. So that is called the specific heat. The thermal expansion, there are some materials, okay, which expands due to the application of heat. There are some materials which carry heat, okay, that is called thermal conductivity. And there are magnetic properties and electric properties, okay. So those will also be coming in related chapters. I said that I'll be talking about mechanical properties, and out of these properties, as you can see on the slide, elasticity, plasticity, and ductility. About these three properties, we'll be discussing in details when we'll be learning steel. Okay, at that time we'll be seeing more in details about these properties. For example, elasticity. Elasticity is the property of a material which allows it to return to its original shape and size after the load to which it is subjected is released. That means you apply load to a material, okay, and then there will be some deformation in the size and shape of the material. Then you take back the load, the material will regain its shape. This property is known as elasticity. And opposite to elasticity is plasticity. Okay, so if a material is elastic, so once the load is released, it will get back its shape. But in case of plastic material, okay, the material, after crossing the elastic limit, it will not regain its original shape once the load is removed. And ductility, it indicates the ability of a material to deform the plastic range without breaking. That means after elastic limit, when the plastic state starts, the material will be subjected to deformation. So ductility is an indication of the deformation, and it continues before the material breaks. Malleability, okay, it is related to plastic deformation of material, but here the load is different. Okay, you know about the compression load and tension load. You know about the stem compression and tension, okay, in some of the classes. So malleability is the property which is related to compression, and normally it is more applicable for materials. For example, plain sheets. Plain sheets, you understand plain sheets? Okay. So plain sheets actually, when the load is applied in the form of compression, so actually they spread. Okay. So then we will tell that the plain sheet is malleable. Okay. Toughness. Toughness is the ability of a material to absorb energy. It has got some unit, and actually it indicates the plastic deformation and without fracturing, and it is also within the plastic range. That means within the plastic range, how much actually energy a material can absorb. So toughness indicates that. The hardness actually it is not related to strength. Actually, it indicates the resistance of a material to permanent deformation on the surface. Okay, we say that some material hard or some material soft. Okay, how do we say that? Because once, for example, if you take a material made of steel, if you try to make and scratch, or if you try to make a cut, okay, if the material is hard, and it becomes very difficult to make an impression on the material, okay, that means to make a deformation. Or some materials may be used in some industrial plant, okay, so where they're subjected to mechanical wear and tear. So if the material is hard, it will be less subjected to wear and tear. So that means there will be less amount of deformation. So hardness actually it is more related to the surface of the material. Okay. So most well-known hard metal is diamond. You know that to cut diamond, actually you need separate instruments or equipment. Okay. So a diamond is the hardest of all materials. Okay. And soft material, okay, aluminum is a soft material, or plastic is a soft material. Okay, because it is easy to make some impression on the surface of aluminum or plastic. Then slip. Slip means the plastic deformation which happens in a material. Okay, here what happens? You know, the materials are actually, if you break down the materials, at one stage you will find atoms, isn't it? So atoms are arranged in various layers or planes. Okay, so when due to the application of load, when one layer or plane of atoms glides or shifts, okay, to another one or shifts away, that is called slip. Fatigue is action of repeated or fluctuating stresses. You can relate fatigue, okay, for example, in case of highway pavement, the pavement is subjected to fatigue. Fatigue load means the pavement is subjected to continuous actually plying of vehicles. That means the surface is coming under repeated load. Okay, so that is called fatigue. Creep is the phenomenon of continuous gradual extension under a steady force. For example, if you take a spring, and if you hang a load at the end of the spring, and then you keep it like that, and you will find that slowly over the period of time, the materials will actually increase. Okay, that means its length will increase with the passage of time. It will take time, but it will happen. That is called creep. It means the gradual extension under a steady force. The force remains steady, but the deformation takes place, or the extension takes place gradually over a long period of time. That is called creep. About creep, and there is another term called force relaxation. We'll be learning these issues when we'll be talking about the stress and strain, okay, in that lecture. Brittleness, you understand, some material brittle. Brittle means in Bengali it is bongus, okay. So the brittle materials, so what happens when the load is applied, they actually breaks or falls suddenly under pressure, and then it doesn't give any warning. That means that if a metal is not brittle, once you apply load, what will happen? For example, if you talk about steel, So it still is not a brittle material. It still is a ductile material. Ductile material means it will after crossing the elastic limit, and then it will have the plastic limit, and at that time actually it will be subjected to deformation. Okay, but in case of brittle material, and then you will understand that the changes are happening. But in case of brittle material, actually there will not be any deformation, and the material will collapse suddenly. Resilience, the ability to absorb energy in the elastic range. So elastic range, elasticity we discussed. That means if you apply load, okay, there will be some deformation, and then you take back the load, the material regains its shape. So within the elastic range, the material, the energy it absorbs, that is called resilience. There's a difference between resilience and toughness. But toughness is happening in the beyond the elastic range, that is in the plastic range, the amount of energy the material takes. Resilience is related to elastic range. Then stiffness, it is the rigidity of an object. That means the extent to which it can resist deformation, okay, when a force is applied. Okay, so that means it is actually a force, okay, and how much force it can resist. That is called stiffness. In this slide, you can see this type of slide will be seen in steel and also in stress strain chapter also. I'm just introducing it. This slide shows the stress strain curve for a ductile material. Okay, so what happens if you take the example of steel bars or rivers or the rod that we use in the construction building? Actually, those materials are tested in the laboratory, okay, for their strength test. So such a material, okay, when it is subjected to load, what happens at the initial stage? The material remains. Here you can see in this chart, the x-axis shows the strain, okay, and then strain means the deformation, okay, okay, and stress is the load that you are applying per unit area, okay, so that is the stress, okay. So when material is subjected to load, okay, so within the elastic range, actually the stress and strain are you see the straight line, okay. That means this with certain amount of stress, there will be certain amount of strain, and this stress and strain, these two are proportional, okay. And then after this mark, this is also within the elastic limit, but here stress and strain, the relationship is not proportional. But within this range, if you take back the load, the material will regain its shape, okay. So this is called the elastic limit, okay, or elastic region. And then yield point is the point from where the deformation will take place. Because after this point, if you take back the load, the material will not gain back its shape. Okay, that means the material has entered into the plastic region. And then if you keep on increasing the load here in this graph, though the graph is showing like that, but in some materials you will see the graph is going like that. That means the okay, the stress reaches to a maximum value, that is called ultimate stress, and then graph comes down like that. So here for this graph, this is the ultimate strength. That means this is the maximum amount of strength. This one, this value. If you come towards left, so more or less 98, okay, is the ultimate strength of this material. And after that, if you the material will be subjected to rupture, that means the material will collapse. So in general, these are the properties of the material, and this type of slides we'll be seeing in future more. We talked about toughness and resilience, and I already said that resilience, it is within the elastic range. As you can see this part, okay, where the stress strain ratio is proportional, and after that, and this part, okay, this is called the plastic range. The deformation is taking place, okay, and then gradually with the increase of load, stress, the strain also increases and it reaches to maximum point. Okay, however, so the toughness is the total area under this curve, this part, the white part, that is called toughness. Okay, and then the resilience is the area indicated by black in this chart. Okay, which is happening within the elastic range. Okay, that means the amount of energy the material can absorb. Okay, if it is in elastic range, that's resilience. If it is in plastic range, then it is toughness. This slide shows actually okay, 3 types of material. Typically, this is stress. Okay, this is strain, and the blue one. So blue one indicates the brittle material. So the material is brittle material. Actually, they're strong, but the problem is that there is no strain. So you see, this shows strain. So here, if you come to this point, the stress is very high, but the strain is very little. Okay, and it does not have any plastic deformation stays. Okay, this one, the red one, this is also strong material, but this is also not ductile. That means it can take less amount of strength. Okay, but strain range is more. Here, strain range is very less. This is the strain range. Here, strain range is more. Okay, and it also breaks suddenly. So both brittle material and this material, okay, the difference is that one can take more strength, one can take less strength, but both the material are actually breaks suddenly. This one is the material actually ductile material, the normal reinforcement bar or rebar that we use in construction of buildings. Okay, so that is the standard typical cut. Okay, so initially when the material is subjected to load, for example, a steel rebar is tested in the lab by fixing it in a ETM machine. Okay, and then we'll show in later classes the arrangement, and we'll also do the sectional in the laboratory, or by this time most of you have done it. We have done it. So initially, when the load is applied, so this is the elastic range, and then this is the yield point, and then this is the plastic range. Then the material reaches to its ultimate strength. Okay, and at one stage it collapses. Okay, that is called the rupture point. So ductile material after the elastic region. Okay, you see there is some strange things are happening here. You see the value is increasing, then it is going down, and again going up. So this part is called necking. It's called necking. Hello. Keep yourself in muted conditions. Okay, this is called necking. And why does that happen? This fall and again rise, we'll be discussing in later classes. For the time being, you know that what is the curve of a brittle material, then what is the curve of a ductile material. And this is a plastic material. It has got very small elastic region. Hardly there is any elastic region, but it is ductile in nature. But that means it will be subjected to deformation at very low stress. This slide shows actually okay, high carbon steel, medium carbon steel, and low carbon steel. For high carbon steel, this is the strongest one. That means it can take more amount of stress, but this is ductile in nature. Okay, for medium carbon steel, okay, this is its ductility is moderate, and low carbon steel it is more ductile, so it can take less strength, but it will be subjected to deformation for a longer period. Okay. That's all about the remaining part of from the aggregate. Okay, while today we discussed about the properties of engineering materials. Okay, now we'll see our today's main lecture. There is cement. Lecture 4. The topics which will be covered here, as you can see on the slide: the types, competition, manufacture, process, some of the properties, tests, and hydration. So hydration and tests, that will be tests will be covered in the next lecture, lecture 5, and hydration and other details will be hydration and other things will be covered in lecture 6. Okay, let's see how much you can pass it today. Cement. What is cement? We have got some general idea what is cement. We know that it is a one kind of building material. Okay, popular building material. Because why it is popular? Because there are popular means when we say something is popular, that means there are other things which are not popular. That means there are some other alternatives of cement. That means there are some other materials like cement, like lime. Lime is also.
Slide দেখতে পাচ্ছি না।
Slide দেখতে পাচ্ছ না? Okay, sorry. Slide share দেওয়া হয় না মনে হয়। ঠিক আছে, okay, দাঁড়া, let me back. Can you see the slide down? Can you see the slide down?
Sir, yes, sir. দেখতে পাচ্ছি, sir.
That is the first slide of cement, lecture 4 and 5. We will be talking about lecture 4, and these are topics which will be covered: composition, manufacture, types, properties, tests, and hydration. I said that, okay, today most probably will be confining ourselves after manufacturing. We may proceed further. The tests, the other issues will be covered in lecture 5. Hydration will be covered in lecture 6. I'm talking about this slide, okay? Okay, I said that there are a lot of building materials, okay? Cement is a popular one, and there are popular means there are other materials similar to cement, like lime, but cement is more popular. Why? We'll see in the next slide. Cement is a material which has got both adhesive and cohesive properties. There is a difference between adhesion and cohesion. Can anyone say what the difference between adhesion and cohesion? What is adhesion and what is cohesion? Anyone from the class? No, none. If you someone to respond, otherwise I'll select by name.
Sir, প্রশ্নটা বুঝতে পারিনি, sir.
Difference between adhesion and cohesion. If you can see the slide, it shows that, okay, material with adhesive and cohesive properties. That means cement is both adhesive and cohesive. What is the difference between adhesion and adhesiveness or cohesiveness, or adhesion or cohesion? Okay, material is adhesive means, and that means you can fix the material. Okay.
Sir, the tendency of two or more defined molecules to bond with each other is the adhesion.
Sorry.
Sir, the tendency of two or more molecules to to make a bond with each other is the cohesion, is the addition, and the attraction force between the same molecule is the cohesion, sir.
Okay, so that is in terms of molecule. Okay, I accept that thing. But in terms of cement, when we talk about cement, for example, cement paste, or the cement when it is mixed with water, so that means you can fix it to the wall, to some wall, okay, or cement. Okay, if you use it with aggregate, so with the aggregate surface, cement, okay, will make a bond. Okay, that means addition. The cement is adhesive. That means the cement paste is making a bond. Okay, that means to the surface of the aggregate. Okay, it হচ্ছে ওটা লেগে থাকার মতো আর কি, adhesiveness. আর cohesiveness হচ্ছে that aggregate and cement together they're making a bond. They're more cohesive. হ্যাঁ, এটা হচ্ছে তোমার হচ্ছে এই অ্যাডহেসিভটা হচ্ছে মানে তোমার গায়ে লেগে থাকার মতো, আর কোহেসিভটা হচ্ছে যে টুগেদার টু ডিফারেন্ট ম্যাটেরিয়ালস মেকিং এ স্ট্রং বন্ড, ওকে, something like that. And about cement, okay, what is cement? There are some other definitions like any material that binds or unites, that is called cement. We have a normal perception of cement, but any material, okay, which can bind or unite something, that is called cement. Okay. Okay. Then to bind the sand and coarse aggregate together. So in case of concrete, pen cement concrete or reinforced cement concrete, actually the purpose of cement is to bind the coarse aggregate, that is the big chips or stone chips, and the fine aggregate, that is the sand. So it bind and make a strong bond, okay, between this fine aggregate and the core aggregate, and make it very cohesive one. And another purpose of cement is to fill the voids. You know, cement is a very fine particle. So, and in aggregate gradation, we have seen that there are coarse aggregates, there are fine aggregates. Okay, in fine aggregates there are sands, and then you know that between the aggregates there are some voids. So what happens? The fine aggregates occupies the space between the coarse aggregates. Still, there are some voids are remaining within the fine aggregates. That is within sand. So that void within the sand is filled up by cement. So cement has got that purpose also. And then all together, cement with other fine aggregate and coarse aggregate make a compact mass. There are some related terms. Okay, these terms will be coming later also as an introduction. There are few terms like setting out, hardening, and hydration. Setting out means that means the change from a fluid to a rigid state. That means the change of state. Okay, that means when you mix water with cement, okay, you see that a paste is formed, and gradually, if you keep it like that, then from the fluid state over the period of time, it will take the shape of a rigid one. So that is called the change of state. That is called the setting out. It has got no relationship with the strength. It is only the change of state. And hardening refers to actually strength. It means the gaining of strength, okay, of the cement paste. So initially, actually, during the setting out stage, actually, though hardening starts from the beginning, and initially the strength is very less over the period when actually when the setting out is complete. That means when the material transformed from the fluid state to rigid state. So in the rigid state or the solid state, the material will gain some strength. That is called hardening. And third term is hydration. Hydration means the chemical reaction. That means hydration, you understand that when water is added to cement, some chemical reaction takes place. That is called hydration. So about hydration, we have a separate lecture 6. Here we'll discuss the difference between cement and lime. You know, lime is also one type of cement. Cement, I said that cement is a most popular building material. So cement has got some cementing property. That means it makes bond. So actually, cement actually as a building material, and then actually it is used for last maybe 100 years, and then 130 or 40 years, maybe. I'm not very sure. At least in this subcontinent, first cement plant was established in 1908. Okay, so before that, people used to construct buildings before the invention of cement. So at that time, lime was the people used to use lime in place of cement before the invention of cement. So and gradually, when cement was invented, people switched over from lime to cement. There's a difference between cement and lime because lime is white, and we know cement is gray, but cement can be manufactured in other colors also. We are talking about the difference between cement and lime. We talked about setting out. That means change of state. Okay, so cement starts setting within 10 to 30 minutes, and it acquires strength. That means hardening. It acquires strength in a day or two. Though later on we'll learn that this gaining of strength has got various phases. Okay, 7 days strength, 20 days strength, like that, and there are various ingredients which are responsible, which contributes to gain that strength. We'll be learning this most of the today. For lime, it took us more time for setting and also for gaining strength. Cement is several times stronger binding material than lime. One advantage is that. And then one of the disadvantages of lime is that it damages iron girders and other fittings. So in old days, when there were no cement, people used to use lime. So at that time, actually, there are no concrete buildings. Okay, concrete buildings means reinforced concrete buildings, because people started making reinforced concrete buildings from last century actually. Okay, but before that, people used to make buildings with the help of lime, and the people used to use the iron girders. Okay, like that. So at that time, it has been seen that the lime, due to its chemical composition, there are some ingredients in lime which react with the girders, the iron part. Okay, and there are some other fittings. So, but cement, in case of cement, you don't see that. So cement can protect the metallic fittings. And when water is added, okay, both for cement and heat, cement and lime, the heat is generated. In case of lime, for example, more or less, for all of you, you have lime in your house. If you have your grandparents are staying with you, isn't it? Did you get my question? যাদের বাসায় দাদি নানি আছে তাদের বাসায় লাইম আছে। কি ফর্মে আছে লাইমটা? লাইম মানে কি?
চুন ফর্মে।
Chun, right? Okay. So you know that grandfathers or grandmothers, or maybe the people those who work in the house, they take this lime in the form of chun. So most of you have seen that when you add water, okay, and then after that, if you start to feel, you feel that heat, that the huge amount of heat is being generated. So it is in a small capacity. But in case of construction, when you add water with the lime, huge amount of heat is generated. Okay, in case of lime. But in case of cement also heat is generated, but this heat generation is unnoticeable, negligible. Okay, but again, this is not that much negligible, because if the construction work is very huge, okay, or you are going for massive construction, where for example concrete constructions, okay, maybe you are making an earth dam, and then you are making it with concrete, or you are using cement. At that time, you see that huge amount of heat will be produced. Okay, and that heat produced by cement is not negligible. There some other additives or admixtures are used to reduce the heat of the cement. Just for now, know that, learn that between lime and cement, heat generation is more for lime than cement. In case of cement, it is unnoticeable. Though later we learn that in case of cement also, if it is huge volume, it has got some significant impact. And cement cannot be used for whitewashing. Lime we can use for whitewashing, isn't it? But cement we cannot use for whitewashing. So this is the difference between cement and lime. Then we'll be talking about the type of cement, natural cement and artificial cement. So from ancient days, people used to use, besides lime, they used to use cement, some other forms. They used to collect natural stones, they used to burn it, and they used to crush it, and they used to make it powders. Okay, because from the experience, okay, they came to know that certain stones, if they're burned and then crushed, and then they have some cementing properties. So over the period of time, people learn, and then and then in terms of those stones, actually the two types of the stone. One is called argillaceous matter, that is which is basically a combination of silica and alumina, clay, and stones which contains 20 to 40% of argillaceous matter, and rest are calcareous matter like limestone or chalk. Okay, so we said about natural stones. Actually, these stones are having 20 to 40% of argillaceous matter, and the rest are calcareous matter. And in case of natural cement, which are produced from natural stones, okay, the property varies from place to place. because stones, natural stones, which are used in stones which are used in USA, which are used in China, natural stones which are used in some other places. So actually the properties vary from place to place and because of these reasons. The setting times also varies from 5 minutes to 5 hours because these are the natural stones. So you cannot control those setting time properties. Okay, people are not able to control that. So, and then it has been found that the high percent of clay material, okay, are available because as you can see that argillaceous matter, this clay matter is 20 to 40%. Okay, so clay is very fine material. So actually, the more a material is finer, that means it has got the more it has got space available for chemical reaction with water. So that means the more the rapid the chemical reaction is, the rapid will be the setting. That means rapid will be the change of state. So due to the presence of clay matter, so in case of natural cement, which is coming from natural stone, the setting time used to be very quick. Okay, but strength, ultimate strength, actually was very less. Okay, okay. But if the clay material is less, then the result is different, that opposite. In ancient days, people used to use Roman cement. Okay, that means which is basically clay, and it is strength is 1/3 of present day's artificial cement. Present day, the cement that we use is called artificial cement. So in ancient days, people used to use the Roman cement, some part of the world. Okay, so strength was 1/3 of present day's ordinary cement or Portland cement or normal cement. And another one is called Pozzolana cement. Pozzolana cement actually, okay, the name comes, it's Italian word. Actually, it is also cement. Actually, the source of this cement is the volcanic clay, because they used to use in ancient days the volcanic clay as cementing material, because the pozzolana means capability of making bond. So that clay was able to make bond. Okay, and at that time, in case of pozzolana cement, the problem is that their hardening process was very slow. Hardening means the gaining of strength. So in pozzolana cement, their strength gaining process was very slow. So that's all about the natural cement. Before the invention of artificial cement or present cement, people used to use either lime or natural cement from which they used to get from natural stones. And then people invented artificial cement later on. Okay, that means the present cement. What is artificial cement? It is a mixture of argillaceous and calcareous substances. Okay, but they are maintained in proper ratio. Okay, because you artificially you are making it. Here also, procedure remains same. The materials are mixed in right proportion. Then they are burned at high temperature, and then due to burning at high temperature, then a material is produced that is called clinker. You are oriented with this term clinker. Okay, so and then clinkers are produced. Then that clinkers are crushed so that it becomes fine powder. That means the cement that you see, there is a fine powder. So that is actually nothing. Mixture of those argillaceous or calcareous materials, okay, which are burned at high temperature, which formed clinkers. So in our country, actually, we import clinkers from outside, and then those clinkers are crushed to make fine powder, because we don't have actually these argillaceous or calcareous substances available. Okay, in Bangladesh, in Sylhet, and the Holcim Lafarge, okay, they have a plant near the border, and they carry being limestones, okay, and then other materials, so conveyor belts from across the border to their factory, which is located near the border, okay, in Bangladesh part, and there they use the clinkers by themselves. Otherwise, in Bangladesh, in almost all the cement factories, they actually import clinkers from outside. And that's why you will see that maximum of the cement factories are located beside some river, because those clinkers are imported from abroad. It comes to Chittagong port, and then it remains in some deep sea cargo ship, and then it is transported to a smaller cargo ship, and then it is being transported through the inland waterways, and then it is coming to the factory, which is located beside the river or some water sources. And then when clinkers are crushed to fine powder, then you add gypsum. That means, what is gypsum? Calcium sulfate, and it has got some water with it. What is the purpose of adding gypsum? Because if you use gypsum, gypsum itself is also a cement, okay? So you use gypsum because it delays the setting action. Setting action means change of state. Why do you need to change the state? Why do you need to change the state? Because if the setting action is very fast, because then it will actually affect your mixing, application, and fixing. For example, what do you do? What do you do in case of plain cement concrete, or in case of cement mortar? Cement mortar means mixture of cement, sand, and water. So that is used for plastering. You know plastering. By the same, you are supposed to know. Then plain cement concrete means mixture of cement, sand, and coarse aggregate. There is no reinforcement bar. And reinforced concrete, you understand, cement, sand, then stones, and then you used the reinforcement bar. Okay. So when you mix, sand, cement, water, and a stone, okay, you place it some places, if you do it manually, or you place it in some mixing plant. So then you add water, okay. Then a paste is formed, and then you have to keep it, carry it to the site, and then you have to apply it. So that means at that time you need to keep the material in a, if not liquid, in a semi-solid state. So you add gypsum so that the setting action, that the change of state actually is delayed. So main purpose of adding gypsum is to delay the setting action of cement, so that you have sufficient time, okay, which will help you in mixing, application, and fixing, okay. And natural artificial cement is also known as normal setting cement, ordinary cement, or Portland cement. This cement, actually, present cement was first invented by a mason, not an engineer, or not a chemical engineer. Mason, on earlier days, his name was Joseph Aspdin of England in 1824. Okay, now we know that cement was first invented in 1824. That means before 1824, there are a lot of structures, though at that time, those are made of either lime, because there is no cement, or made of natural cement, which we have discussed in the previous slide. So when Joseph Aspdin from England invented cement in 1824, which is commonly known as Portland cement, why it is called Portland cement? Because in England, there's an area named Portland, and there was sandstone was available. From that sandstone, they used to prepare cement. That's why it is called Portland cement. Okay. In India, that means in this subcontinent, first cement factory was established in India in 1904. That means almost after 80 years of its invention in Europe. Okay. This slide shows the composition of ordinary cement. Okay, we said that cement is made of argillaceous and calcareous material, but if you go into more details, if you see the constituents, what materials makes actually those materials. Okay, that is, one is called alumina or clay. Now we are talking about going into the more details. Okay. So, and chemical names we are coming to know. So, one is clay or alumina. This is the chemical formula. And normally, typical percentage is 5%. silica, silica oxide, 22%, lime, okay, the metal component, steel, okay, 62%, and there are other elements like iron oxide, 3%, magnesium oxide, 2%, sulfur trioxide, 1%, alkalis, means sodium hydroxide or potassium hydroxide, 1%, then gypsum. I said the gypsum is added, okay, it's 4%. Typically, in an artificial cement, actually, this is the proportion, okay? And actually, these are actually the various companies when they produce cement, so they have to keep these constituents within the range. For example, for alumina, the range is 3 to 8%. So we're talking about the typical cement, okay, for this case. So here they have kept alumina 5%. Means whatever value you see here, those are within the range. That means you have to, that has to be within the range. Now, these constituent materials have got certain job functions, okay? Because alumina or clay, actually, it is responsible for setting action. Setting action means change of state. So alumina, okay, contributes to set the action and set the cement. And if there is excess amount of alumina, it will make the cement weak one. Then silica oxide, what is its job? It is responsible to impart strength. We talked about hardening. That means in the process of hardening, cement gains strength. So silica is responsible for imparting strength to the cement. We talked about lime, calcium oxide. So this is the most important element because it makes actually almost 60% of the total contents. And then if the lime is excess, okay, and then excess amount of lime is used to the cement, then some of it remains as a free lime. That means it does not take part in the chemical reaction of the manufacturing process of cement, and it remains as free lime, which later on causes expansion and disintegration of cement during setting and hardening. So right proportion of lime should be used. And if you use less lime, that will also cause decrease in strength, okay? Because cement, which ultimately will make a bond, okay, and which will give a strength. So if you use less amount of lime, it will decrease the strength. And other elements, though used in small proportions, okay, like these elements, iron oxide, and then 3%, 2%, 1%, 1%, 4%, they also have some role. For example, iron oxide imparts color of the cement. It also helps to increase the strength and hardness of the cement. Magnesium oxide, it also imparts strength and hardness of the cement, okay, when it is available in small amount. Sulfur trioxide, okay, small percentage of sulfur actually make the cement sound. What is soundness of cement? We actually will be learning at a later stage, okay, soundness of cement. Then alkalis, actually excess of alkalis. Alkalis means either sodium or potassium oxides, okay, that cause efflorescence in the cement. Efflorescence, you understand efflorescence because I think you have learned it, or you're learning it in excess of alkalis, that is the oxide of sodium, cause efflorescence. In buildings, you'll see outside the wall, you'll see the deposition of actually some white materials, okay, that is very troublesome. So that happens, that white powders, okay, that is called efflorescence. And actually, if that happens due to the presence of alkalis, okay, and actually, if you don't treat that, that will cause disintegration of concrete. Then gypsum or calcium sulfate, then 2H2O amount of water, it is used to retard, okay, the setting action or prolong the setting action of cement. So this is very important. This is very important that what are the constraint components of cement and what are the function of these constraint components of cement for use all types of exam. Types of cement, there are two types: hydraulic cement, the normal cement, and then it's called non-hydraulic cement. Hydraulic cement means Actually, the hydraulic very name indicates that they sets and hardens because of water, like normal cement or Portland cement. Okay, and then non-hydraulic cement are lime and gypsum, that they are called non-hydraulic cement because they don't need water to form a solid product. And then mixtures made from cement is very simple issues like cement grout, cement mortar, and cement concrete. Okay, cement grout is a mixture of cement and water only. Okay, and why do you use it? এটা তোমার যে four finish হিসেবে ইউজ করা হয় cement grout. Cement mortar, you understand, cement, sand, and water. It makes a paste, and it is used for plastering. And concrete, you understand that when you use cement, sand, and some stone chips or brick chips, that will make cement concrete. So that's all today. I think our time is over, isn't it? We have some time.
No, sir. আমাদের টাইম শেষ হয়ে গেছে।
This part, manufacture of cement, we'll be discussing in next class. Thank you.
আসসালামু আলাইকুম।